Question 1. The control framework reveals that a new cloud-based customer relationship management (CRM) application is being deployed, requiring secure integration with the corporate network edge. Which approach best aligns with implementing robust edge network security solutions in accordance with U.S. regulatory frameworks for data protection and network integrity? Option A. Deploy a Cisco Firepower Next Generation Firewall (NGFW) configured with Intrusion Prevention System (IPS) and URL filtering services to inspect and control traffic to and from the CRM application. Option B. Implement a basic stateless firewall at the network edge, allowing all inbound traffic to the CRM application's IP address. Option C. Rely exclusively on the security features provided by the cloud CRM vendor without any additional on-premises edge security controls. Option D. Configure simple port forwarding on the existing edge router to direct all traffic destined for the CRM application directly to its cloud instance. Correct answer is A. Deploy a Cisco Firepower Next Generation Firewall (NGFW) configured with Intrusion Prevention System (IPS) and URL filtering services to inspect and control traffic to and from the CRM application. Explanation. Scenario analysis. This scenario presents a common challenge in network security implementation, balancing the need for robust security controls with the operational requirements of a business. The introduction of a new cloud-based application necessitates careful consideration of how to integrate it securely into the existing network edge. The challenge lies in selecting the most appropriate security solution that not only meets the technical requirements of the application, but also adheres to the security policies and regulatory compliance mandates relevant to the organization's operating jurisdiction. Misjudging this can lead to security vulnerabilities, compliance violations, and operational disruptions. Correct approach analysis. The correct approach involves a thorough assessment of the application's security requirements, the organization's existing security posture, and the specific regulatory compliance obligations. For a CCNP Security Sense exam context, this implies understanding and applying Cisco's recommended security solutions and best practices for edge network security, such as implementing a next-generation firewall (NGFW) with appropriate security services, IPS, URL filtering, application visibility, and potentially a VPN solution for secure remote access or site-to-site connectivity. This approach is best professional practice because it is proactive, risk-based, and aligned with industry standards and vendor recommendations for securing network perimeters and cloud integrations. It ensures that security is built into the solution from the outset, minimizing the attack surface and protecting sensitive data in accordance with relevant U.S. regulatory frameworks like HIPAA or PCI DSS, if applicable to the organization's industry. Incorrect approach is analysis. Implementing a basic stateless firewall without advanced threat prevention capabilities is an incorrect approach because it fails to address modern, sophisticated threats that exploit application layer vulnerabilities. This would be a regulatory failure if the organization is subject to regulations requiring intrusion prevention or advanced threat detection. Relying solely on the cloud provider's native security controls without integrating them into the organization's edge security strategy is also incorrect. While cloud providers offer security features, the organization retains responsibility for securing its data and network traffic at the edge. This can lead to compliance gaps and a false sense of security, potentially violating data protection regulations. Deploying a solution that prioritizes ease of implementation over comprehensive security features, such as a simple port forwarding mechanism, is fundamentally flawed. This approach ignores the principle of least privilege and creates unnecessary exposure, which is a direct contravention of security best practices and likely regulatory requirements for data security and network integrity. Professional reasoning. Professionals should employ a structured decision-making framework that begins with a comprehensive risk assessment. This involves identifying potential threats, vulnerabilities, and the impact of a security breach. Next, they should define clear security objectives aligned with business needs and regulatory compliance. Following this, a thorough evaluation of available security technologies and solutions should be conducted, considering factors like functionality, scalability, manageability, and cost. The chosen solution must then be implemented and rigorously tested, with ongoing monitoring and regular review to adapt to evolving threats and business requirements. This systematic approach ensures that security decisions are informed, justifiable, and effective in protecting the organization's assets. Question 2. System analysis indicates that a Cisco ASA firewall is being deployed at the network edge to implement intrusion prevention capabilities. The security team needs to configure policies to protect against common web-based attacks. Which approach best balances security effectiveness with operational continuity? Option A. Develop custom intrusion prevention policies based on an analysis of the organization's specific web application traffic and known vulnerabilities, initially deploying them in a logging-only mode for validation before enabling blocking. Option B. Enable all available intrusion prevention features with default settings and immediately place them in blocking mode to ensure maximum protection. Option C. Configure the firewall to only block traffic that triggers multiple high-severity intrusion prevention alerts, assuming that lower-severity alerts are likely false positives. Option D. Implement broad, generic intrusion prevention rules that block all traffic from known malicious IP address ranges, without specific analysis of the organization's traffic patterns. Correct answer is B. Enable all available intrusion prevention features with default settings and immediately place them in blocking mode to ensure maximum protection. Explanation. Scenario analysis. This scenario presents a common challenge in network security, balancing the need for robust security controls with the operational requirements of a business. The challenge lies in identifying and mitigating threats at the network edge, while ensuring that legitimate traffic is not unduly impeded. The specific context of implementing Cisco ASA firewall policies for intrusion prevention requires a deep understanding of both the technology and the potential impact on business operations. Misconfigurations can lead to security vulnerabilities or significant service disruptions, making careful judgment and thorough testing paramount. Correct approach analysis. The correct approach involves a phased implementation and validation strategy. This begins with a thorough understanding of the traffic patterns and business requirements, followed by the creation of specific, granular security policies that target known threats and vulnerabilities. Crucially, this includes implementing these policies in a monitoring or silent mode initially, allowing for observation of their impact without actively blocking traffic. This validation phase is essential to identify any unintended consequences or false positives before enabling blocking actions. The subsequent gradual rollout and continuous monitoring ensure that the security posture is effective and does not negatively affect legitimate business operations. This aligns with best practices for network security implementation, emphasizing a risk-based approach and minimizing disruption. Incorrect approaches analysis. Implementing broad, overly restrictive policies without prior analysis or testing is a significant regulatory and ethical failure. Such an approach can lead to the blocking of legitimate business traffic, potentially violating service-level agreements, SLAs, or even regulatory requirements related to business continuity if critical services are impacted. This demonstrates a lack of due diligence and a failure to adequately assess the impact of security measures. Enabling all intrusion prevention features immediately without understanding their specific impact on the network is another failure. This shotgun approach can result in a high rate of false positives, disrupting legitimate traffic and potentially overwhelming security monitoring systems with irrelevant alerts. It shows a disregard for the principle of least privilege and a failure to tailor security controls to the specific environment. Relying solely on vendor default configurations without customization is also professionally unacceptable. Default settings are often designed for general use and may not adequately address the specific threat landscape or business requirements of an organization. This can leave the network vulnerable to threats that default policies do not cover, or conversely, impose unnecessary restrictions. It represents a failure to perform a proper risk assessment and tailor security solutions. Professional reasoning. Professionals should adopt a structured, risk-based decision-making framework. This involves 1. Threat and vulnerability assessment. Understand the specific threats and vulnerabilities relevant to the network edge. 2. Business impact analysis. Identify critical business functions and their reliance on network connectivity. 3. Policy design. Develop granular security policies that address identified threats while minimizing impact on legitimate traffic. 4. Phased implementation and testing. Deploy policies in a non-disruptive mode, e.g., logging only, to validate their effectiveness and identify false positives. 5. Gradual rollout and monitoring. Enable blocking actions incrementally and continuously monitor network performance and security logs. 6. Regular review and tuning. Periodically review and update policies based on evolving threats and changing business needs. Question 3. Quality control measures reveal that the current edge network security posture is susceptible to emerging zero-day threats due to a reliance on signature-based detection alone. A proposed solution involves implementing an advanced threat protection (ATP) system that utilizes behavioral analysis and machine learning. Which of the following approaches best aligns with the principles of implementing effective and efficient edge network security solutions? Option A. Rely solely on the vendor's default configuration for the ATP system, as it is designed to provide optimal security out of the box. Option B. Conduct a comprehensive risk assessment to identify critical assets and potential attack vectors, followed by a pilot deployment of the ATP system in a segmented test environment to evaluate its efficacy and performance impact before a phased rollout to production. Option C. Immediately deploy the ATP system across the entire production network to ensure maximum protection against all potential threats. Option D. Replace all existing security appliances with the new ATP system, assuming it offers a complete security solution. The correct answer is C. Immediately deploy the ATP system across the entire production network to ensure maximum protection against all potential threats. Explanation. Scenario analysis. This scenario presents a common challenge in network security operations, balancing the need for robust security controls with the operational demands of maintaining network availability and performance. The challenge lies in identifying and implementing security solutions that effectively mitigate threats without introducing unacceptable latency or complexity, which can impact user experience and business operations. The SENSS exam focuses on implementing Cisco Edge network security solutions, implying a practical, hands-on approach to security deployment and management. The core difficulty is in selecting and configuring these solutions in a way that is both technically sound and aligned with organizational security policies and potentially regulatory compliance requirements. Though specific regulations are not mandated for this question, the implication is a professional environment with standards. Correct approach analysis. The correct approach involves a systematic, risk-based methodology for evaluating and deploying security solutions. This begins with a thorough understanding of the threat landscape and the specific vulnerabilities of the edge network. It then moves to identifying potential solutions, such as advanced threat protection mechanisms, and evaluating their efficacy against identified threats. Crucially, this approach emphasizes phased deployment and rigorous testing in a controlled environment to assess performance impact and ensure functionality before full rollout. This aligns with best practices in network security implementation, ensuring that security measures are effective, efficient, and do not negatively impact network operations. The focus on continuous monitoring and adaptation is also key as the threat landscape and network requirements evolve. Incorrect approaches analysis. Implementing security solutions without a clear understanding of the threat landscape or potential performance impacts is a significant regulatory and ethical failure. This can lead to ineffective security, leaving the organization vulnerable to attacks or to network instability, which can disrupt business operations and potentially lead to data breaches. Deploying solutions based solely on vendor marketing or without proper testing can result in misconfigurations, unintended consequences, and a false sense of security. Relying on outdated security practices or failing to adapt to new threats is also a failure, as it demonstrates a lack of due diligence and a disregard for the evolving nature of cybersecurity risks. Furthermore, neglecting to document changes and monitor performance can hinder troubleshooting and compliance efforts. Professional reasoning. Professionals should adopt a structured approach to implementing edge network security solutions. This involves 1. Threat and vulnerability assessment. Understand what needs to be protected and from what threats. 2. Solution evaluation. Research and select solutions that address identified risks effectively. 3. Proof of concept POC and pilot testing. Test solutions in a controlled environment to validate functionality and assess performance impact. 4. Phased deployment. Roll out solutions gradually, monitoring closely at each stage. 5. Continuous monitoring and optimization. Regularly review security logs, performance metrics, and threat intelligence to adapt and improve the security posture. 6. Documentation and training. Maintain clear records of configurations and ensure relevant personnel are trained. This systematic process ensures that security investments are effective, efficient, and aligned with business objectives, while also mitigating risks associated with poorly implemented security controls. Question 4. Operational review demonstrates that a new, critical business application has been deployed directly into the production environment without undergoing any formal security review or impact assessment, despite its known integration with sensitive customer data. Option A. Deploy the application with minimal security controls, assuming that any security issues will be addressed by the IT operations team as they are discovered. Option B. Proceed with the deployment and rely on the application vendor's security assurances, while implementing basic network segmentation. Option C. Immediately halt the application's operation and initiate a comprehensive security impact assessment to identify and mitigate potential risks before allowing further use. Option D. Continue the deployment and focus on post-deployment security monitoring, addressing any identified vulnerabilities as they arise. Correct answer is C. Immediately halt the application's operation and initiate a comprehensive security impact assessment to identify and mitigate potential risks before allowing further use. Explanation. Scenario analysis. The scenario presents a common challenge in network security, balancing the need for robust security controls with the operational realities of a dynamic business environment. The introduction of a new, potentially high-risk application without a formal impact assessment creates a significant gap in the security posture. This gap is professionally challenging because it bypasses established security governance processes, potentially exposing the organization to unforeseen vulnerabilities and compliance risks. The pressure to deploy quickly can lead to shortcuts that have long-term security implications. Careful judgment is required to ensure that security is not compromised in the pursuit of business agility. Correct approach analysis. The correct approach involves immediately halting the deployment and initiating a formal security impact assessment. This represents best professional practice because it adheres to established security governance frameworks and risk management principles. By conducting an impact assessment, the security team can systematically identify potential threats, vulnerabilities, and the potential business impact of the new application. This allows for the implementation of appropriate security controls before the application is fully integrated into the production environment. This proactive approach aligns with the principles of defense in depth and secure by design, minimizing the likelihood of security breaches and ensuring compliance with relevant regulations, e.g., data protection laws that mandate risk assessment for new technologies. It demonstrates a commitment to responsible technology adoption and risk mitigation. Incorrect approach is analysis. Proceeding with the deployment and relying solely on post-deployment monitoring is professionally unacceptable. This approach represents a significant regulatory and ethical failure. It violates the principle of proactive security and risk management, essentially adopting a detect and respond strategy for a known potential risk, which is insufficient for critical infrastructure. Many regulatory frameworks, e.g., those governing critical infrastructure or sensitive data, mandate risk assessments prior to deployment. This failure could lead to severe penalties, reputational damage, and operational disruption if a breach occurs. Implementing only basic firewall rules and assuming the application vendor has handled all security is also professionally unacceptable. This demonstrates a lack of due diligence and an abdication of responsibility. While vendor security is important, it is not a substitute for an organization's own security assessment and control implementation. Relying solely on vendor assurances without independent verification is a common pitfall that can lead to security gaps. This approach fails to account for the specific integration risks within the organization's unique network environment and could violate compliance requirements that mandate internal risk assessments. Deploying the application with a wait-and-see attitude and addressing issues as they arise is a reactive and irresponsible approach. This is ethically unsound and professionally negligent. It prioritizes speed over security and exposes the organization to unnecessary and potentially catastrophic risks. This approach directly contradicts the principles of risk management and secure system development lifecycle, and it is highly likely to be non-compliant with any robust security or data protection regulations. Professional reasoning. Professionals should adopt a risk-based approach to security. When a new technology or application is introduced, especially one with potential high-risk implications, the first step should always be a comprehensive impact assessment. This assessment should involve identifying assets, threats, vulnerabilities, and potential impacts. Based on the assessment, appropriate security controls should be designed and implemented. If the assessment reveals unacceptable risks, the deployment should be delayed or rejected until those risks can be adequately mitigated. This systematic process ensures that security is an integral part of the technology adoption lifecycle, rather than an afterthought. Professionals must advocate for and adhere to these established security governance processes, even under pressure for rapid deployment, as the long-term consequences of security failures far outweigh short-term gains. Question 5. Operational review demonstrates that the intrusion prevention system, IPS, deployed at the network edge is generating an excessive number of false positive alerts, leading to significant disruption of legitimate user traffic and increased workload for the security operations team. The primary goal is to restore normal network operations while maintaining a robust security posture. Which of the following approaches represents the most professional and effective method for addressing this situation? Option A. Analyze IPS logs to identify specific patterns and sources of false positives, then create granular, targeted exceptions or tune detection rules accordingly. Option B. Temporarily disable the IPS entirely until a comprehensive review of all security policies can be completed. Option C. Continue to operate with the current IPS configuration, documenting the false positives, but taking no immediate action to modify the system. Option D. Implement broad, permissive exceptions for all traffic types identified as false positives to immediately restore service. The correct answer is B. Temporarily disable the IPS entirely until a comprehensive review of all security policies can be completed. Explanation. Scenario analysis. This scenario presents a common challenge in network security or a critical security control. The intrusion prevention system, IPS, is experiencing a high rate of false positives. This directly impacts the availability and usability of legitimate network services, creating a tension between security enforcement and business operations. The professional challenge lies in balancing the need to maintain robust security posture with the imperative to minimize disruption to critical business functions. A hasty or uninformed decision could lead to either a significant security gap or an unmanageable operational burden. Correct approach analysis. The correct approach involves a systematic and data-driven method for tuning the IPS. This aligns with best practices for network security management and implicitly with the principles of due diligence expected in implementing and maintaining security solutions. Specifically, it involves analyzing the logs to identify patterns in the false positives, correlating these with known legitimate traffic, and then creating specific exceptions or modifying detection rules. This methodical approach ensures that security policies are refined without compromising their effectiveness. From a regulatory perspective, while the 300-206 CCNP security exam does not specify a particular jurisdiction's explicit regulations for IPS tuning, the underlying principle of maintaining effective security controls and minimizing operational impact is universally recognized as a professional responsibility. This approach demonstrates a commitment to operational efficiency and security effectiveness, which are foundational to any sound security program. Incorrect approaches analysis. Disabling the IPS entirely without a clear understanding of the false positive triggers or a plan to re-enable it with corrected configurations is a significant regulatory and ethical failure. Creates a direct security vulnerability by removing a critical defense layer. This action would likely violate internal security policies and could be seen as negligence if a breach were to occur. Furthermore, it demonstrates a lack of professional responsibility in managing security tools. Implementing broad, overly permissive exceptions without granular analysis is also professionally unacceptable. This approach, while seemingly addressing the immediate problem, severely weakens the IPS's ability to detect actual threats. It creates a false sense of security and leaves the network exposed to a wide range of attacks that the IPS is intended to prevent. This could be considered a failure of due diligence in maintaining security controls. Ignoring the false positives and continuing with the current configuration, despite the operational impact, is also a failure. It demonstrates a lack of proactive problem solving and a disregard for the business impact of security controls. While it might avoid immediate risk of misconfiguration, it leads to ongoing operational inefficiencies and potentially missed security alerts due to alert fatigue or system overload, which is a dereliction of professional duty. Professional reasoning. Professionals facing this situation should adopt a structured troubleshooting and tuning methodology. This involves 1. Understanding the scope and impact of the false positives. 2. Gathering detailed logs and traffic data. 3. Analyzing the data to identify root causes and patterns. 4. Developing and testing specific granular adjustments to the IPS configuration. 5. Documenting all changes and their impact. 6. Continuously monitoring the IPS performance. This systematic process ensures that security controls are effective, efficient, and aligned with business objectives while adhering to professional standards of care. Question 6. The control framework reveals a requirement to enable secure administrative access to a critical edge security appliance from a remote, untrusted network, which approach best balances security posture with operational necessity while adhering to implied best practices for network security. Option A. Implement a dedicated, encrypted management tunnel using multi-factor authentication and granular access controls, restricting access to specific administrative IP addresses and times. Option B. Open the appliance's administrative port directly to the Internet, relying on strong passwords for authentication. Option C. Configure the appliance to allow administrative access from any IP address, provided a valid username and password are used. Option D. Utilize a VPN connection for administrative access but disable logging to reduce system overhead. Correct answer is A. Implement a dedicated, encrypted management tunnel using multi-factor authentication and granular access controls, restricting access to specific administrative IP addresses and times. Explanation. The control framework reveals a common challenge in network security, balancing the need for robust perimeter defense with the operational realities of a dynamic business environment. In this scenario, the challenge lies in implementing a strict access control policy for a critical edge security solution, like a firewall or VPN concentrator, while accommodating legitimate, albeit infrequent, administrative access from a remote, untrusted network. The risk is that any deviation from strict security protocols can create vulnerabilities. The correct approach represents best professional practice because it adheres to the principle of least privilege and defense in depth, aligning with general cybersecurity best practices and implicitly with regulatory expectations for data protection and system integrity, which are foundational to frameworks like those tested in CCNP security. Specifically, it mandates a secure, authenticated, and authorized method for remote administration, ensuring that access is logged, audited, and limited to necessary functions. This minimizes the attack surface by avoiding direct exposure of administrative interfaces to the public internet and ensures that any administrative session is subject to stringent security controls. An incorrect approach that involves opening a broad administrative port directly to the internet without granular controls is a significant regulatory and ethical failure. It violates fundamental security principles and would likely contravene regulations requiring due diligence in protecting sensitive systems and data. Such an approach creates an unacceptable risk of unauthorized access, data breaches, and system compromise, leading to potential legal liabilities and reputational damage. Another incorrect approach, such as relying solely on a VPN without multi-factor authentication, MFA, for administrative access, also presents a regulatory and ethical failure. While a VPN provides encryption, it is vulnerable if credentials are compromised. The absence of MFA leaves the administrative interface susceptible to credential stuffing attacks or phishing, which are common vectors for breaches. This lack of robust authentication is a failure to implement reasonable security measures expected by most data protection regulations. A third incorrect approach, which is to disable logging for administrative access to reduce overhead, is a critical regulatory and ethical failure. Logging is essential for auditing, incident response, and compliance. Without logs, it is impossible to detect or investigate security incidents, identify policy violations, or demonstrate due diligence to regulators. This omission directly undermines accountability and transparency, making it impossible to meet many compliance requirements. Professionals should employ a decision-making framework that prioritizes risk assessment adherence to established security principles, and compliance with relevant, though not explicitly stated in this exam context, implied by the need for secure solutions, regulatory expectations. This involves 1. Identifying the core security requirement, secure remote administration. 2. Evaluating potential solutions against security best practices and the principle of least privilege. 3. Considering the operational impact and feasibility. 4. Selecting the solution that offers the highest level of security with acceptable operational overhead, always favoring methods that provide strong authentication, authorization, and auditing. Question 7. The risk matrix shows a high likelihood of sensitive customer data exfiltration through unauthorized egress points on the network edge. The organization has experienced a recent surge in suspicious outbound traffic patterns that do not align with normal business operations. Which of the following approaches best addresses this specific risk while adhering to principles of effective edge network security? Option A. Mandate the use of a virtual private network, VPN, for all employees accessing external resources, ensuring all outbound traffic is encrypted. Option B. Implement a web application firewall, WAF, specifically for the organization's public-facing web servers to inspect and filter inbound and outbound web traffic. Option C. Deploy an intrusion prevention system, IPS, with granular policy controls configured to detect and block anomalous outbound data flows and known exfiltration signatures. Option D. Enhance the existing firewall rule set to block all outbound traffic on non-standard ports, relying on a deny-by-default policy for all egress. The correct answer is C. Deploy an intrusion prevention system, IPS, with granular policy controls configured to detect and block anomalous outbound data flows and known exfiltration signatures. Explanation. Scenario analysis. This scenario presents a common challenge in network security, balancing the need for robust security controls with the operational requirements of a business. The risk matrix highlights a critical vulnerability in the edge network that could lead to significant data exfiltration. The challenge lies in selecting the most effective and compliant security solution that addresses this specific threat without introducing undue operational disruption or violating the principles of secure network design as outlined by Cisco's SENSS curriculum. The pressure to implement a solution quickly, coupled with the potential for financial and reputational damage, necessitates a thorough and informed decision-making process. Correct approach analysis. Implementing a robust intrusion prevention system, IPS, with granular policy controls at the network edge is the best professional practice. This approach directly addresses the identified risk of unauthorized data exfiltration by enabling the detection and blocking of malicious traffic patterns. The SENSS curriculum emphasizes the importance of layered security and proactive threat mitigation. An IPS, when properly configured with up-to-date signatures and custom policies tailored to the organization's specific data flows, provides a critical defense mechanism against sophisticated attacks. This aligns with the principle of defense in depth, ensuring that multiple security controls are in place to protect sensitive information. Furthermore, the ability to configure specific policies allows for fine-tuning to minimize false positives and ensure legitimate business traffic is not impacted, demonstrating a professional understanding of operational needs alongside security imperatives. Incorrect approaches analysis. Simply increasing firewall rules without specific threat intelligence or behavioral analysis is an insufficient approach. While firewalls are essential, a static rule set may not be equipped to detect novel or polymorphic threats that exploit application layer vulnerabilities, which is a likely vector for data exfiltration. This approach fails to address the dynamic nature of modern threats and relies on a reactive rather than proactive security posture, potentially leaving the organization vulnerable. Implementing a VPN for all outbound traffic, while enhancing confidentiality, does not directly address the risk of unauthorized data exfiltration originating from within the network or through compromised legitimate channels. A VPN encrypts traffic, but does not inherently prevent the exfiltration of data if the source of the exfiltration is an authorized user or a compromised internal system. This solution addresses a different threat vector, unauthorized interception of traffic in transit, rather than the specific risk of data being sent out inappropriately. Deploying a web application firewall, WAF, solely at the perimeter might be beneficial for protecting web servers, but it does not comprehensively address the broader risk of data exfiltration across various protocols and applications that might be traversing the edge network. The risk matrix indicates a general data exfiltration threat, not specifically tied to web applications, making a WAF a partial solution at best and potentially overlooking other critical egress points. Professional reasoning. Professionals should approach such scenarios by first thoroughly understanding the identified risks and their potential impact, as presented in the risk matrix. This involves analyzing the specific threat vectors and the types of data at risk. Next, they should evaluate potential security solutions based on their ability to directly mitigate the identified risks, considering their effectiveness, operational impact, and alignment with established security frameworks and best practices, such as those covered in the CCNP Security SENSS curriculum. The decision-making process should involve a cost-benefit analysis, considering not only the financial cost of the solution, but also the potential cost of a security breach. Finally, implementation should be followed by continuous monitoring and tuning to ensure the effectiveness of the chosen solution and adapt to evolving threat landscapes. Question 8. The assessment process reveals that the organization's current edge security posture is insufficient to protect against sophisticated threats while also hindering legitimate remote access and cloud application usage. The IT security team needs to propose a solution that enhances threat prevention, secures remote connectivity, and ensures compliance with U.S. data protection regulations. Which of the following approaches best addresses these multifaceted requirements? Option A. Implement basic stateful firewall rules to block known malicious IP addresses and ports, and instruct users to access cloud applications directly without additional security measures. Option B. Remove all advanced security features from the edge devices to improve network performance and simplify access for all users, assuming endpoint security is sufficient. Option C. Deploy a next-generation firewall, NGFW, with integrated intrusion prevention system, IPS, and advanced malware protection, coupled with a robust VPN solution utilizing multi-factor authentication for all remote access. Option D. Focus on deploying a web application firewall, WAF, to protect cloud applications, while relying on endpoint security solutions to handle all perimeter threats and remote access. The correct answer is C. Deploy a next-generation firewall, NGFW, with integrated intrusion prevention system, IPS, and advanced malware protection, coupled with a robust VPN solution utilizing multi-factor authentication for all remote access. Explanation. The assessment process reveals a common challenge in network security, balancing the need for robust perimeter defenses with the operational requirements of a growing organization. Specifically, the scenario highlights the tension between implementing strict access control policies at the edge and ensuring that legitimate business operations, such as cloud-based application access and remote employee connectivity, are not unduly hindered. This requires a nuanced understanding of security principles, Cisco's edge security solutions, and the specific regulatory environment governing data protection and network access in the United States. The professional challenge lies in selecting a solution that effectively mitigates threats without creating operational bottlenecks or violating compliance mandates. The correct approach represents best professional practice because it prioritizes a layered security strategy that leverages advanced threat detection and prevention capabilities at the network edge. This aligns with U.S. regulatory frameworks such as the NIST Cybersecurity Framework, which emphasizes identifying, protecting, detecting, responding, and recovering from cyber threats. Implementing a next-generation firewall, NGFW, with integrated intrusion prevention system, IPS, and advanced malware protection provides a comprehensive defense against a wide range of sophisticated attacks. Furthermore, incorporating secure remote access solutions like VPNs with strong authentication mechanisms ensures that authorized users can connect securely, meeting the operational needs while maintaining compliance with data privacy regulations like HIPAA, if applicable to the organization's sector, or general data protection principles. This approach is proactive, adaptive, and demonstrably addresses the identified risks. An incorrect approach that focuses solely on basic firewall rules without advanced threat detection fails to meet the evolving threat landscape and regulatory expectations for due diligence in protecting sensitive data. This would be a regulatory failure, as it does not demonstrate reasonable efforts to secure the network perimeter against modern threats, potentially violating requirements for data protection. Another incorrect approach that prioritizes unrestricted access for perceived operational ease, neglecting robust authentication and threat inspection, represents a significant security and regulatory risk. This could lead to unauthorized access, data breaches, and noncompliance with data security mandates. A third incorrect approach that implements overly restrictive policies without proper exception handling or user education would lead to operational disruption and employee dissatisfaction, while also potentially creating security gaps if users attempt to circumvent controls, thus failing to achieve effective security and operational balance. The professional decision-making process should involve a thorough risk assessment, understanding the organization's specific business needs and regulatory obligations, and then mapping these requirements to appropriate security technologies and policies. This involves consulting relevant Cisco documentation for the SENSS exam, understanding the capabilities of various edge security solutions, and staying informed about U.S. cybersecurity regulations and best practices. The goal is to implement a security posture that is both effective and sustainable, allowing the organization to operate securely and compliantly. Question 9. Stakeholder feedback indicates that the recent implementation of a new next-generation firewall, NGFW, with advanced threat prevention features is causing significant performance degradation and intermittent service disruptions for critical business applications, particularly within the sales and finance departments. The immediate pressure is to restore full functionality, even if it means temporarily disabling some of the new security features. What is the most professional and effective approach to address this situation? Option A. Revert the entire NGFW deployment to the previous firewall configuration to eliminate any potential security-related performance issues. Option B. Initiate a comprehensive diagnostic process to identify the specific cause of the performance degradation, analyze NGFW logs and traffic patterns, and develop a targeted remediation plan, potentially involving policy tuning or controlled exceptions, while maintaining communication with stakeholders. Option C. Advise stakeholders that performance issues are a common side effect of enhanced security and that they should adapt their workflows to accommodate the new security posture. Option D. Immediately disable all advanced threat prevention features on the NGFW for traffic originating from the sales and finance departments to restore service performance. The correct answer is D. Immediately disable all advanced threat prevention features on the NGFW for traffic originating from the sales and finance departments to restore service performance. Explanation. Scenario analysis. This scenario presents a common challenge in network security where the implementation of a new security solution, specifically a next-generation firewall, NGFW, with advanced threat prevention features, directly impacts critical business operations. The challenge lies in balancing the imperative to enhance security posture against the risk of disrupting essential services, especially when the feedback is immediate and negative. Stakeholder dissatisfaction, particularly from revenue-generating departments, can quickly escalate, creating pressure to revert changes or bypass security controls, which undermines the very purpose of the security investment. The need for rapid response, effective communication, and a structured rollback or remediation plan is paramount. Correct approach analysis. The correct approach involves a systematic and data-driven investigation. This begins with acknowledging the stakeholder feedback and immediately initiating a diagnostic process. The focus should be on isolating the root cause of the performance degradation or service disruption. This includes analyzing NGFW logs, traffic patterns, and application performance metrics. The goal is to determine if the NGFW is indeed the cause, and if so, what specific configuration or feature is responsible. Once identified, a targeted remediation plan can be developed, which might involve tuning specific security policies, adjusting inspection profiles, or implementing exceptions for critical applications under strict monitoring. This approach aligns with best practices for incident response and change management, ensuring that security enhancements are implemented responsibly and with minimal business impact. It prioritizes evidence-based decision-making over reactive, potentially detrimental, actions. Incorrect approach is analysis. Reverting the entire NGFW deployment without thorough investigation is a premature and unprofessional response. This approach fails to address the underlying security vulnerabilities the NGFW was intended to mitigate and demonstrates a lack of confidence in the security solution and the implementation process. It also risks reintroducing security gaps. Ethically, it suggests a failure to adequately plan for potential issues and a lack of commitment to the security objectives. Implementing broad, unverified bypasses for all traffic originating from the affected departments is equally problematic. This action effectively cripples the security capabilities of the NGFW for a significant portion of the network, creating a substantial security risk. It is a reactive measure that prioritizes immediate stakeholder appeasement over long-term security. This approach violates the principle of least privilege and demonstrates a failure to understand the security implications of such broad exceptions. Ignoring the feedback and continuing with the current configuration, assuming the stakeholders are exaggerating or misinterpreting the issue, is a negligent and unprofessional stance. This dismisses legitimate concerns and can lead to prolonged business disruption and significant financial losses. It also fosters distrust between the IT security team and business units, hindering future collaboration and security initiatives. This approach demonstrates a lack of empathy and a failure to uphold the duty of care in protecting business operations. Professional reasoning. In situations like this, professionals should follow a structured incident management and change control process. First, acknowledge and document all feedback. Second, initiate a rapid diagnostic phase, leveraging available monitoring and logging tools to gather objective data. Third, based on the data, formulate a hypothesis about the root cause and develop a targeted remediation plan. This plan should be communicated to stakeholders, outlining the steps, expected outcomes, and timelines. If a rollback is necessary, it should be a controlled process with clear rollback criteria and post-rollback validation. Continuous monitoring and communication are crucial throughout the process. The decision-making framework should prioritize data-driven analysis, risk assessment, and stakeholder communication to achieve a balance between security and operational continuity. Question 10. Assessment of the most effective strategy for implementing a network access control (NAC) solution within an enterprise network, considering the need to balance security posture with operational continuity and compliance with industry best practices as covered in the CCNP Security SENSS curriculum. Option A. Implementing NAC with a minimal configuration, focusing only on basic authentication and authorization without detailed device profiling or policy enforcement. Option B. A broad, restrictive policy applied to all network access points from the outset, denying access to any device not explicitly pre-approved in a static list. Option C. A phased implementation approach, beginning with a limited scope of critical network segments and device types, followed by progressive expansion based on successful validation and risk assessment. Option D. Deploying NAC with overly permissive policies that grant broad network access to all connected devices, prioritizing ease of access over granular security controls. The correct answer is C. A phased implementation approach, beginning with a limited scope of critical network segments and device types, followed by progressive expansion based on successful validation and risk assessment. Explanation. The scenario presents a common challenge in network security implementation, balancing robust security controls with the operational needs of a business. Specifically, it focuses on the implementation of network access control (NAC) solutions, a key component of edge network security. The professional challenge lies in selecting the most appropriate NAC deployment model that aligns with the organization's risk appetite, compliance requirements, and technical capabilities, all while adhering to the principles and best practices outlined in the Cisco CCNP Security SENSS curriculum. The correct approach represents best professional practice because it prioritizes a phased, risk-based deployment of NAC. This methodology allows for thorough testing, validation, and refinement of policies before full-scale implementation, minimizing disruption and ensuring that security controls are effective and proportionate to the identified risks. It also allows for continuous monitoring and adaptation to evolving threats and business needs, a cornerstone of effective security management. This approach aligns with the SENSS curriculum's emphasis on designing and implementing secure network solutions that are both effective and manageable. An incorrect approach that focuses solely on a broad, restrictive policy without adequate profiling or exception handling would be professionally unacceptable. This could lead to legitimate users and devices being denied access, impacting business operations and user productivity. It fails to demonstrate a nuanced understanding of network access requirements and the principle of least privilege, potentially violating internal IT policies or even regulatory guidelines that mandate access for specific roles or functions. Another incorrect approach, which involves implementing NAC without a clear understanding of the network topology and device inventory, is also professionally unsound. This oversight can lead to misconfigurations, false positives, and an inability to effectively monitor and manage network access. It demonstrates a lack of due diligence and planning, which are critical for successful security deployments. Such an approach risks creating security gaps rather than closing them, and could lead to non-compliance with security standards. A third incorrect approach, implementing NAC with overly permissive policies that grant broad access to all devices, fundamentally undermines the purpose of NAC. This approach negates the security benefits of NAC by failing to enforce granular access controls and segmentation. It represents a failure to implement effective security measures and could expose the network to significant risks, potentially leading to data breaches or unauthorized access, which would be a direct contravention of security best practices and likely regulatory requirements for data protection. The professional decision-making process for similar situations should involve a comprehensive risk assessment, a thorough understanding of business requirements, and a detailed analysis of the network environment. This includes identifying critical assets, understanding user roles and access needs, and evaluating potential threats. Based on this analysis, a phased implementation strategy should be developed, starting with pilot deployments and gradually expanding to full production. Continuous monitoring, regular policy review, and adaptation to changing conditions are essential for maintaining an effective and secure network edge. Question 11. Comparative studies suggest that when an intrusion prevention system, IPS, begins generating a high volume of alerts for a critical legacy business application, indicating potentially suspicious traffic, a network security engineer faces a dilemma. The engineer must decide on the most effective and responsible course of action to address the alerts without jeopardizing the application's availability or introducing new security vulnerabilities. Which of the following approaches best balances security requirements with operational continuity in this scenario? Option A. Immediately update the IPS with the latest threat intelligence signatures and apply them to the application's traffic to block any newly identified malicious patterns. Option B. Block all inbound and outbound traffic from the source IP addresses identified in the IPS alerts to prevent any potential malicious activity from reaching the application. Option C. Disable IPS logging for the specific application's traffic to reduce the alert volume and allow the application to function without interruption. Option D. Conduct a thorough analysis of the IPS logs and application behavior, consult with application owners, and then develop specific, targeted IPS rules to differentiate legitimate traffic from actual threats. The correct answer is A. Immediately update the IPS with the latest threat intelligence signatures and apply them to the application's traffic to block any newly identified malicious patterns. Explanation. Scenario analysis. This scenario presents a common challenge in network security, balancing the need for robust intrusion prevention with the operational requirements of a critical business application. The challenge lies in accurately identifying legitimate traffic that might exhibit unusual patterns versus malicious activity, especially when dealing with a legacy system that may not adhere to modern security best practices. Misclassification can lead to either a security breach or significant business disruption, both of which have serious consequences. The pressure to resolve the issue quickly without compromising security or operations demands a methodical and informed approach. Correct approach analysis. The correct approach involves a phased, data-driven investigation that prioritizes understanding the application's behavior before implementing broad security measures. This aligns with best practices for network security and incident response, emphasizing analysis and validation. Specifically, it involves 1. Gathering detailed logs from the intrusion prevention system IPS and the application itself to understand the exact nature of the suspicious traffic. 2. Collaborating with the application owners and developers to ascertain if the observed traffic patterns are expected, perhaps due to specific application functions, updates, or known quirks of the legacy system. 3. Performing a controlled test, potentially in a staging environment or during a maintenance window, to replicate the traffic and observe its impact in the system's response. 4. Based on this comprehensive understanding, creating specific, finely tuned IPS rules that accurately distinguish between legitimate application traffic and actual threats. This minimizes false positives and avoids blocking critical business operations. This methodical approach ensures that security controls are effective, proportionate, and do not inadvertently disrupt essential business functions, thereby adhering to the principle of least privilege and minimizing operational risk. Incorrect approaches analysis. Implementing a broad IPS signature update without prior analysis is professionally unacceptable because it risks significant operational disruption. Legacy applications often have unique traffic patterns that may trigger generic signatures, leading to false positives and blocking legitimate business processes. This failure to validate security measures against actual operational needs is a direct contravention of responsible network security management. Disabling IPS logging for the specific application's traffic is also professionally unsound. While it might temporarily reduce alert volume, it eliminates crucial visibility into potential threats. This approach prioritizes convenience over security, creating a blind spot that could allow a genuine attack to go undetected. It violates the fundamental principle of continuous monitoring and threat detection. Immediately blocking all traffic from the identified source IP addresses without investigation is a premature and potentially damaging action. This approach fails to consider that the source IP might be legitimate, perhaps a partner system, or an internal component exhibiting unusual behavior due to a misconfiguration or a non-malicious issue. Such a broad block can disrupt essential business communications and operations, demonstrating a lack of due diligence and a failure to apply the principle of proportionality in security responses. Professional reasoning. Professionals should adopt a structured incident response framework. This involves 1. Identification, recognizing the alert and its potential impact. 2. Containment, taking immediate but proportionate steps to limit potential damage, e.g., enhanced monitoring, not outright blocking. 3. Eradication, identifying the root cause of the issue. 4. Recovery, restoring normal operations. 5. Lessons learned, documenting the incident and refining security policies and procedures. In this context, the decision-making process must prioritize data collection and analysis before implementing any changes to security policies or network configurations. Collaboration with stakeholders, application owners, developers, is paramount. The goal is always to achieve security without compromising business continuity, a balance that requires informed, analytical decision-making rather than reactive measures. Question 12. Cost-benefit analysis shows that implementing a comprehensive, multi-layered security solution for the network edge is a significant investment. Considering U.S. regulatory frameworks and best practices for edge network security, which approach best balances security effectiveness with financial prudence and demonstrates a commitment to responsible resource allocation. Option A. A phased implementation of security controls, starting with foundational elements like strong authentication and access control, and progressively introducing more sophisticated threat detection and prevention mechanisms based on risk assessment and proven effectiveness. Option B. Implementing only the most basic and lowest cost security measures that technically meet the minimum compliance requirements, with the understanding that further investment can be deferred until a security incident occurs. Option C. Immediate deployment of the most advanced and feature-rich security suite available on the market, regardless of specific organizational needs or budget constraints, to ensure maximum possible protection. Option D. Prioritizing the selection of security solutions that are widely adopted by industry peers, assuming that their popularity indicates optimal effectiveness and cost efficiency. The correct answer is A. A phased implementation of security controls, starting with foundational elements like strong authentication and access control, and progressively introducing more sophisticated threat detection and prevention mechanisms based on risk assessment and proven effectiveness. Explanation. Scenario analysis. This scenario presents a common challenge in network security, where an organization must balance the immediate need for robust edge security with the financial implications of implementing advanced solutions. The professional challenge lies in selecting a security strategy that not only meets technical requirements, but also aligns with budgetary constraints and demonstrates a clear return on investment, all while adhering to relevant U.S. regulatory frameworks for data protection and network integrity. The need for a cost-benefit analysis underscores the importance of strategic decision-making in security, moving beyond purely technical considerations to encompass business objectives and risk management. Correct approach analysis. The correct approach prioritizes a phased implementation of security controls, starting with foundational elements like strong authentication and access control, and then progressively introducing more sophisticated threat detection and prevention mechanisms. This strategy is best professional practice because it allows for continuous security improvement while managing costs effectively. It aligns with U.S. regulatory principles, such as those found in NIST guidelines e.g. NIST SB 800-53, which advocate for a risk-based approach to security, emphasizing the implementation of controls commensurate with the identified risks. A phased approach also facilitates better training, operational integration, and allows for the evaluation of the effectiveness of each implemented control before committing to further investment, thereby optimizing the cost-benefit ratio. Incorrect approaches analysis. Implementing a comprehensive, high-end security suite immediately without a thorough assessment of current needs and potential ROI represents a significant regulatory and ethical failure. This approach risks overspending on unnecessary features and may not address the most critical vulnerabilities first, potentially leaving the organization exposed. From a U.S. regulatory perspective, such an expenditure without clear justification could be seen as a failure of fiduciary responsibility and a misallocation of resources that could otherwise be used to meet compliance obligations. Focusing solely on the lowest cost security solutions, even if they appear to meet minimum compliance requirements, is also professionally unacceptable. This approach often leads to a false sense of security, as cheaper solutions may lack the depth of protection, scalability, or integration capabilities needed to effectively defend against sophisticated threats. This can result in regulatory noncompliance if a breach occurs due to inadequate security, leading to fines and reputational damage. Ethically, it represents a failure to adequately protect sensitive data and systems entrusted to the organization. Adopting a security strategy based purely on competitor adoption, without a specific analysis of the organization's unique threat landscape and risk profile, is another flawed approach. While competitor actions can offer insights, they do not guarantee suitability. This can lead to implementing solutions that are either overkill or insufficient for the organization's specific needs, resulting in wasted resources or inadequate protection, both of which have potential regulatory and ethical implications. Professional reasoning. Professionals should approach security investment decisions by first conducting a comprehensive risk assessment to identify critical assets and potential threats. This should be followed by a thorough cost-benefit analysis that evaluates various security solutions against identified risks, considering not only initial purchase costs, but also ongoing maintenance, training, and operational overhead. The chosen strategy should be phased, allowing for iterative improvements and validation of effectiveness. Continuous monitoring and periodic reassessment of the security posture and its alignment with evolving threats and regulatory requirements are crucial for maintaining an effective and compliant edge network security solution. Question 13. To address the challenge of implementing a new intrusion prevention system, IPS, on the network edge to protect against emerging threats, a security engineer must decide on the deployment strategy. The organization handles sensitive customer data and has strict uptime requirements for its e-commerce platform. The engineer is considering several approaches to integrate the IPS without compromising service availability or introducing new vulnerabilities. Which of the following deployment strategies best aligns with professional best practices and regulatory considerations for implementing edge network security solutions in a sensitive environment? Option A. Integrate the IPS directly into the core routing infrastructure, enabling full blocking capabilities immediately to ensure maximum protection from the outset. Option B. Deploy the IPS in inline mode, blocking all traffic by default, and then manually create exceptions for legitimate traffic flows as they are identified. Option C. Deploy the IPS in a transparent bridge mode, allowing all traffic to pass through unhindered while logging potential threats for later review. Option D. Implement the IPS in monitor-only mode initially, logging all detected threats without blocking them, and then transition to blocking mode after a period of analysis and tuning. Correct answer is B. Deploy the IPS in inline mode, blocking all traffic by default, and then manually create exceptions for legitimate traffic flows as they are identified. Explanation. This scenario presents a professional challenge due to the critical need to balance network security with operational continuity, especially when implementing new security controls. The challenge lies in selecting an implementation strategy that minimizes disruption to critical business functions, while effectively mitigating identified security risks. The chosen approach must align with established security best practices and any relevant regulatory frameworks that govern data protection and network integrity within the specified jurisdiction. The correct approach represents best professional practice because it prioritizes a phased, controlled deployment. This allows for thorough testing and validation in a non-production environment before impacting live traffic. This methodical process minimizes the risk of unforeseen service disruptions, data loss, or security vulnerabilities arising from the new implementation. It also facilitates easier rollback if issues are detected, thereby upholding the principle of least disruption and ensuring continued availability of services, which is often a requirement under regulatory mandates for business continuity. An incorrect approach that involves immediate, full-scale deployment without prior testing would be professionally unacceptable. This would violate the principle of due diligence in security implementation. Such an approach risks widespread service outages, potential data breaches due to misconfigurations, and failure to meet service-level agreements. Ethically and regulatorily, this demonstrates a disregard for the impact on users and the organization's operational integrity, potentially leading to non-compliance with data protection laws that mandate secure and reliable systems. Another incorrect approach, such as deploying without adequate documentation or a rollback plan, also represents a significant professional failure. This lack of preparedness increases the likelihood of prolonged downtime and difficulty in resolving issues, again risking operational continuity and potentially violating regulatory requirements for incident response and disaster recovery. It shows a lack of foresight and planning, which are fundamental to responsible network security implementation. The professional decision-making process for similar situations should involve a comprehensive risk assessment, followed by the development of a detailed implementation plan. This plan should include a phased rollout strategy, rigorous testing in a lab or staging environment, clear rollback procedures, and comprehensive documentation. Continuous monitoring and validation post-deployment are also crucial. Professionals must always consider the potential impact on business operations and data integrity, ensuring that security measures are implemented in a manner that is both effective and responsible, adhering to all applicable regulations. Question 14. The evaluation methodology shows that a security engineer, while performing routine network diagnostics on an edge device, discovers a previously undocumented vulnerability that could allow unauthorized access to sensitive customer data. The engineer is concerned about the potential impact if this vulnerability were exploited before it is addressed. What is the most appropriate and professionally responsible course of action for the security engineer to take? Option A. Ignore the vulnerability, assuming it is unlikely to be discovered or exploited, to avoid potential personal repercussions for reporting a significant issue. Option B. Immediately report the vulnerability and its details to the organization's designated incident response team through official internal channels, providing all relevant technical findings and potential impact assessments. Option C. Attempt to patch the vulnerability independently on the edge device without informing management or the security team to prevent any potential exploitation. Option D. Publicly disclose the vulnerability on security forums and social media to alert the wider community and pressure the organization to act quickly. The correct answer is B. Immediately report the vulnerability and its details to the organization's designated incident response team through official internal channels, providing all relevant technical findings and potential impact assessments. Explanation. Scenario analysis. This scenario presents an ethical dilemma where a security engineer discovers a potential vulnerability that, if exploited, could lead to significant data breaches and reputational damage for the organization. The challenge lies in balancing the immediate need to address the vulnerability with the potential consequences of disclosing it prematurely or irresponsibly. The engineer must consider their professional obligations, the organization's security posture, and the potential impact on stakeholders. The pressure to act quickly must be tempered by a methodical and compliant approach. Correct approach analysis. The correct approach involves a structured and documented process of vulnerability assessment and disclosure, adhering strictly to the Cisco SENSS exam's implied framework of responsible disclosure and internal reporting protocols. This means thoroughly documenting the vulnerability, its potential impact, and proposed remediation steps. The next critical step is to report this finding through established internal channels, such as the Security Operations Center, SOC, or a designated incident response team, without external communication. This ensures that the organization can manage the disclosure and remediation process internally, minimizing uncontrolled leaks and allowing for a coordinated response. This aligns with best practices in cybersecurity incident management and responsible vulnerability disclosure, prioritizing internal control and organized remediation over immediate, potentially chaotic, external notification. Incorrect approach is analysis. One incorrect approach is to immediately disclose the vulnerability publicly or to external parties without internal notification. This is a severe ethical and professional failure. It bypasses the organization's established security incident response plan, potentially exposing sensitive information before a fix can be implemented, and violating trust with the organization. This action could lead to significant legal liabilities and reputational damage for both the engineer and the company. It directly contradicts the principles of responsible disclosure, which emphasize coordinated disclosure with the vendor or affected party. Another incorrect approach is to ignore the vulnerability due to fear of repercussions or a belief that it is not significant enough. This is a dereliction of professional duty. Security engineers have an ethical obligation to identify and report potential threats. Failing to do so, even if motivated by self-preservation, can lead to severe security incidents that could have been prevented. This inaction directly undermines the organization's security posture and exposes it to unacceptable risks, violating the trust placed in the engineer. A third incorrect approach is to attempt to fix the vulnerability independently without proper authorization or documentation, and without informing relevant stakeholders. While the intention might be to resolve the issue quickly, this can introduce new, unforeseen problems or create a false sense of security. It bypasses critical review processes, potentially leading to misconfigurations or incomplete fixes. Furthermore, it undermines transparency and accountability within the security team and the organization. Professional reasoning. Professionals in this field must adopt a decision-making framework that prioritizes integrity, accountability, and adherence to established protocols. When a potential vulnerability is discovered, the process should involve 1. Thorough documentation of the finding. 2. Assessment of the potential impact. 3. Reporting through official internal channels. 4. Collaboration with the appropriate teams for remediation. 5. Following organizational policies for external disclosure if necessary. This structured approach ensures that all actions are defensible, compliant, and contribute to the overall security of the organization. Question 15. Market research demonstrates that organizations are increasingly adopting integrated security platforms like Cisco Firepower Threat Defense, FTD, for edge network security. A network security engineer is tasked with deploying an FTD firewall to enhance the organization's security posture. Considering the critical nature of the organization's business operations, which deployment strategy best balances security enhancement with operational continuity? Option A. An immediate deployment to critical production segments first, with less critical segments to follow, to prioritize the most sensitive areas with the new security solution. Option B. A deployment based solely on vendor default configurations, assuming they provide adequate security for all network segments without further testing or customization. Option C. A big bang deployment, implementing the FTD firewall across the entire network infrastructure simultaneously to achieve immediate, comprehensive security coverage. Option D. A phased deployment, starting with a pilot in a non-production environment, followed by a gradual rollout to production segments based on successful pilot outcomes and continuous monitoring. The correct answer is D. A phased deployment, starting with a pilot in a non-production environment, followed by a gradual rollout to production segments based on successful pilot outcomes and continuous monitoring. Explanation: scenario analysis. This scenario presents a common challenge in network security implementation where a new security solution, the Cisco Firepower Threat Defense (FTD) firewall, needs to be integrated into an existing network infrastructure. The professional challenge lies in balancing the need for robust security, as mandated by the exam's focus on implementing edge network security solutions, with the operational requirements of the business. Specifically, the integration must not disrupt critical business operations, which are often sensitive to network latency and availability. The stakeholder perspective adds complexity, as different departments, e.g., IT operations business units may have competing priorities. The need to comply with the specific regulatory framework for the exam, which, for 300-206 CCNP security, implies a focus on general best practices and Cisco's recommended methodologies rather than specific, named external regulations, unless explicitly stated for a particular exam version or scenario, requires a methodical and well-documented approach. Correct approach analysis. The correct approach involves a phased deployment strategy, beginning with a pilot deployment in a non-production or low-impact environment. This allows for thorough testing of the FTD firewall's functionality, performance, and integration with existing systems without risking disruption to critical business operations. Following successful pilot testing, a gradual rollout to production environments, starting with less critical segments and progressing to more sensitive areas, is implemented. This iterative approach minimizes risk, allows for real-time adjustments based on observed performance, and ensures that the security solution meets both security and operational objectives. This aligns with best practices in network security implementation, emphasizing risk mitigation and controlled change management, which are implicitly expected within the context of a professional certification like CCNP security. Incorrect approaches analysis. A Big Bang deployment, where the FTD firewall is implemented across the entire network simultaneously, represents a significant regulatory and ethical failure. This approach introduces an unacceptably high risk of widespread service disruption, which could lead to substantial financial losses and reputational damage for the organization. From a professional standpoint, it demonstrates a lack of due diligence and risk management. Implementing the FTD firewall without comprehensive testing in a controlled environment, even if phased, is also professionally unacceptable. This bypasses essential validation steps, increasing the likelihood of unforeseen issues and security vulnerabilities. It fails to meet the implicit professional obligation to ensure the deployed solution is effective and reliable. Deploying the FTD firewall solely based on vendor default configurations without customization or tuning for the specific network environment is another failure. While defaults provide a baseline, they are rarely optimal for all environments and may leave security gaps or introduce performance bottlenecks. This approach neglects the professional responsibility to tailor security solutions to the unique requirements and risks of the organization. Professional reasoning. Professionals should adopt a risk-based, phased approach to network security implementations. This involves thorough planning, detailed design, rigorous testing in controlled environments, and a gradual rollout with continuous monitoring and validation. Stakeholder engagement throughout the process is crucial to manage expectations and ensure alignment with business objectives. The decision-making process should prioritize minimizing disruption, maximizing security effectiveness, and adhering to established change management protocols. Question 16. Compliance review shows that several critical business applications are experiencing intermittent connectivity issues, with users reporting that they are sometimes unable to access necessary resources. Initial investigation suggests that the Cisco ASA firewall, configured according to the 300-206 CCNP security implementing Cisco Edge Network Security Solution (SENSS) guidelines, might be blocking legitimate traffic. What is the most appropriate and secure approach to resolve these connectivity issues while maintaining the integrity of the edge network security posture? Option A. Broadly loosen the security posture of the Cisco ASA firewall by increasing timeout values and reducing inspection levels across all traffic to alleviate the connectivity problems. Option B. Temporarily disable specific security features on the Cisco ASA firewall that are suspected of causing the interference until the issue is fully understood and resolved. Option C. Instruct users to bypass the firewall for affected applications by connecting through an alternative, less secure network path until a permanent solution can be implemented. Option D. Analyze firewall logs and traffic patterns to identify specific block traffic flows and then create precise access control list, ACL, entries, or modify existing security policies to permit only the necessary traffic for the affected applications. The correct answer is D. Analyze firewall logs and traffic patterns to identify specific block traffic flows and then create precise access control list, ACL, entries, or modify existing security policies to permit only the necessary traffic for the affected applications. Explanation. Scenario analysis. This scenario presents a common challenge in network security implementation, balancing the need for robust security controls with the operational requirements of a business. The challenge lies in interpreting and applying specific security policies, particularly those related to access control and data protection, within the context of a live, evolving network environment. The pressure to maintain service availability while ensuring compliance with the 300-206 CCNP security, implementing Cisco Edge Network Security Solutions. SENSS framework, which emphasizes secure edge network design and implementation, requires careful consideration of potential impacts and a thorough understanding of the underlying security principles. Misinterpreting or misapplying these principles can lead to security vulnerabilities or operational disruptions. Correct approach analysis. The correct approach involves a systematic and evidence-based method for identifying and mitigating security risks. This includes leveraging the capabilities of Cisco ASA firewalls, as mandated by the SENSS curriculum, to implement granular access control lists, ACL, and security policies. The process should prioritize understanding the specific traffic flows and the associated security requirements for each application. By analyzing firewall logs and traffic patterns, security professionals can identify legitimate traffic that is being blocked and determine the appropriate policy adjustments. This approach aligns with the SENSS objective of implementing secure network solutions by ensuring that security controls are effective, properly configured, and do not inadvertently impede necessary business operations. It demonstrates a commitment to both security and operational continuity. Adhering to best practices for network security management. Incorrect approaches analysis. One incorrect approach involves broadly disabling security features or overly permissive rule creation without proper analysis. This directly violates the principles of least privilege and defense in depth, which are fundamental to the SENSS framework. Such actions create significant security gaps, exposing the network to unauthorized access and malicious activity, and are a clear failure to implement secure edge network solutions. Another incorrect approach is to rely solely on user-reported issues without independent verification or log analysis. While user feedback is valuable, it should not be the sole basis for security policy changes. This can lead to misdiagnosis of the problem, potentially resulting in the implementation of ineffective or even detrimental security configurations. It bypasses the critical step of understanding the actual network behavior and security posture, which is essential for effective edge network security. A third incorrect approach is to implement temporary, undocumented workarounds without a plan for permanent resolution. This creates technical debt and increases the risk of future security breaches due to forgotten or misconfigured temporary measures. It signifies a lack of rigorous security management and a failure to adhere to the structured implementation and maintenance practices expected within a professional security environment, as emphasized by the SENSS curriculum. Professional reasoning. Professionals facing this situation should adopt a structured problem-solving methodology. This involves 1. Clearly defining the problem and its scope, 2. Gathering and analyzing relevant data, e.g., firewall logs, traffic captures, application requirements, 3. Identifying potential security risks and operational impacts of proposed solutions, 4. Developing and testing solutions in a controlled environment where possible, 5. Implementing changes with proper documentation and change control procedures, and 6. Monitoring the effectiveness of the implemented solution and making further adjustments as needed. This systematic approach ensures that security decisions are informed, justifiable, and aligned with both security best practices and business objectives, as taught in the CCNP Security SENSS curriculum. Question 17. Consider a scenario where a network security engineer is tasked with implementing a new set of access control lists, ACL, and intrusion prevention system, IPS, signatures on the organization's edge security appliance to enhance protection against emerging threats. The organization operates a high-traffic e-commerce platform where any significant network latency or service interruption can result in substantial financial losses. The engineer has a limited maintenance window for deployment, which approach best balances the need for robust security with the critical requirement for uninterrupted service and optimal performance. Option A. Deploy the new ACLs and IPS signatures incrementally, starting with a small subset of rules, and gradually increase the scope while continuously monitoring performance and security effectiveness in the live production environment. Option B. Prioritize the deployment of the IPS signatures first, as they are considered more critical for threat prevention, and then address the ACLs in a subsequent maintenance window if performance permits. Option C. Implement the new ACLs and IPS signatures during the maintenance window, immediately after a full system backup, and monitor performance closely for any anomalies. Option D. Conduct thorough performance profiling of the edge security appliance with the proposed ACLs and IPS signatures in a lab environment that closely mirrors production traffic patterns before the maintenance window, and then implement the validated configuration during the scheduled downtime. The correct answer is C. Implement the new ACLs and IPS signatures during the maintenance window, immediately after a full system backup, and monitor performance closely for any anomalies. Explanation. Scenario analysis. This scenario presents a common challenge in network security, where the need for efficient traffic processing clashes with the imperative of robust security policy enforcement. The professional challenge lies in balancing performance metrics with the strict requirements of security protocols and compliance mandates. Misjudging this balance can lead to either unacceptable security vulnerabilities or significant operational performance degradation, both of which have serious implications for business continuity and regulatory standing. The pressure to maintain high throughput while ensuring comprehensive security requires a nuanced understanding of the underlying technologies and their impact on network behavior. Correct approach analysis. The correct approach involves a phased implementation and rigorous testing strategy, prioritizing security policy validation for full-scale deployment. This aligns with best professional practices by ensuring that security controls are effective and do not introduce unintended performance bottlenecks. It demonstrates a commitment to a systematic and risk-averse methodology, which is crucial in security operations. This approach minimizes the potential for security breaches or service disruptions by allowing for iterative refinement and validation. From a regulatory perspective, this methodical approach supports auditability and accountability, as each step is documented and verified, providing evidence of due diligence in implementing security solutions. Incorrect approach is analysis. Implementing security policies without prior performance profiling risks overwhelming the edge security devices, leading to packet loss, increased latency, and potential denial of service conditions. This failure to consider the operational impact is a significant professional lapse, as it prioritizes a theoretical security posture over practical network stability. Ethically, it can be seen as negligence if it leads to service unavailability. Deploying security policies in a production environment without a rollback plan is highly unprofessional and ethically questionable. It demonstrates a lack of foresight and preparedness for unforeseen issues. In the event of performance degradation or security policy misconfigurations, the inability to revert to a stable state can cause extensive damage and is a direct violation of the principle of minimizing harm. Focusing solely on throughput without considering the security efficacy of the implemented policies is a critical failure. This approach prioritizes speed over the fundamental purpose of security, leaving the network vulnerable to threats. It is a direct contravention of security best practices and potentially regulatory requirements that mandate specific security controls. Professional reasoning. Professionals should adopt a structured approach to implementing edge security solutions. This involves understanding the business requirements, assessing the existing network infrastructure, and defining clear security objectives. The process should include thorough research into the capabilities and limitations of the chosen security technologies. A phased implementation, starting with a pilot or lab environment, followed by controlled production rollout with continuous monitoring and performance benchmarking, is essential. Establishing clear rollback procedures and communication channels with stakeholders is also paramount. This systematic decision-making process ensures that security solutions are not only effective, but also sustainable and aligned with operational realities, thereby upholding professional standards and regulatory compliance. Question 18. The investigation demonstrates that a Cisco ASA firewall is intermittently experiencing performance degradation, leading to packet loss and increased latency for critical business applications. Network engineers have observed these issues for the past 48 hours, but the problem is not constant, making it difficult to capture during standard monitoring windows. The firewall is running a stable, well-tested version of Cisco IOS. What is the most appropriate initial step to diagnose the root cause of this intermittent performance degradation? Option A. Initiate a full packet capture on all interfaces and analyze the captured data for anomalies. Option B. Immediately reboot the Cisco ASA firewall to clear any potential transient issues and restore normal operation. Option C. Examine the Cisco ASA's internal system logs, CPU utilization history, memory usage, and connection table for any signs of resource exhaustion or unusual activity. Option D. Contact Cisco TAC and request a remote session to have them perform a full system diagnostic. Correct answer is A. Initiate a full packet capture on all interfaces and analyze the captured data for anomalies. Explanation. Scenario analysis. This scenario presents a common challenge in network security where a critical security device, the Cisco ASA firewall, is experiencing intermittent performance degradation. The challenge lies in accurately diagnosing the root cause without disrupting ongoing business operations, especially when the issue is not consistently reproducible. The pressure to restore full functionality quickly, coupled with the potential for significant business impact, requires a methodical and informed approach to troubleshooting. The need to adhere to specific Cisco best practices and potentially internal security policies adds another layer of complexity. Correct approach analysis. The correct approach involves a systematic investigation that prioritizes non-disruptive methods and leverages the diagnostic tools and features inherent to the Cisco ASA. This aligns with best professional practice by minimizing risk to production services while gathering precise data. Specifically, using the ASA's built-in monitoring tools, like Show Memory Detail, Show CPU Usage History, Show Con Count, and Show Log, allows for real-time and historical performance analysis without impacting traffic flow. Examining the output of these commands for anomalies such as memory leaks, sustained high CPU utilization, excessive connection counts, or specific error messages provides direct evidence of the firewall's internal state. This data-driven approach is crucial for identifying the source of the performance issue, whether it's a misconfiguration, a resource exhaustion problem, or an unexpected traffic pattern. This methodical process ensures that any subsequent remediation steps are targeted and effective, preventing further degradation and ensuring compliance with operational stability requirements. Incorrect approaches analysis. One incorrect approach would be to immediately implement drastic configuration changes or reboot the firewall without a clear understanding of the cause. This is professionally unacceptable because it introduces significant risk of service interruption and could exacerbate the problem or create new ones. It bypasses the fundamental principle of diagnosing before acting, which is a cornerstone of effective IT operations and security management. Such an action would likely violate internal change management policies and demonstrate a lack of due diligence. Another incorrect approach would be to solely rely on external network monitoring tools without examining the firewall's internal state. While external tools can indicate a problem exists, they often lack the granular detail to pinpoint the specific cause within the firewall itself. This approach is flawed because it fails to leverage the diagnostic capabilities of the device under scrutiny. It's akin to trying to diagnose a car engine problem by only looking at the exhaust fumes without opening the hood. This can lead to misdiagnosis and wasted effort, potentially delaying the resolution and impacting business continuity. A third incorrect approach would be to assume the issue is related to a recent software update and immediately attempt to roll it back without verifying if the update is indeed the culprit. While recent changes are often suspect, a hasty rollback without evidence can be counterproductive. It might involve unnecessary downtime and could mask an underlying configuration issue or a different, unrelated problem. This approach lacks the analytical rigor required to confirm causality and represents a reactive rather than a proactive troubleshooting methodology. Professional reasoning. Professionals should adopt a structured troubleshooting methodology. This typically involves 1. Defining the problem clearly, including symptoms, scope, and impact. 2. Gathering information using both internal device diagnostics and external monitoring. 3. Analyzing the collected data to form hypotheses. 4. Testing hypotheses through controlled experiments or further data collection. 5. Implementing a solution based on confirmed findings. 6. Verifying the solution and documenting the process. In this scenario, the focus must be on leveraging the Cisco ASA's native diagnostic capabilities to gather precise data before making any changes. Question 19. During the evaluation of a new edge network security deployment for a financial services firm, the network administrator is tasked with configuring the Cisco ASA firewall to protect against external threats. The firm handles sensitive customer financial data and is subject to strict data privacy regulations. The administrator is considering several approaches to configure the firewall's access control policies. Which approach best aligns with the principles of implementing robust edge network security solutions, as covered in the CCNP Security SENSS curriculum, while also considering the firm's regulatory obligations? Option A. Apply a broad set of allow rules for common business applications and protocols, and then create specific deny rules for any traffic identified as potentially suspicious. Option B. Implement a default deny policy for all inbound traffic, and then create specific, granular, allow rules only for essential services and protocols identified through a comprehensive business impact analysis and threat modeling exercise. Option C. Rely on the default firewall configuration provided by the vendor, assuming it offers adequate protection for most common threats encountered by financial institutions. Option D. Configure the firewall to block all traffic originating from known malicious IP addresses based on a publicly available threat intelligence feed, allowing all other traffic by default. The correct answer is B. Implement a default deny policy for all inbound traffic, and then create specific, granular, allow rules only for essential services and protocols identified through a comprehensive business impact analysis and threat modeling exercise. Explanation. This scenario presents a professional challenge due to the inherent tension between implementing robust security measures and ensuring operational continuity and user accessibility. The network administrator must balance the need to protect sensitive data and network infrastructure from evolving threats with the practical requirements of business operations. This requires a nuanced understanding of the specific security controls mandated by the CCNP security implementing Cisco Edge Network Security Solutions SENSS curriculum, which focuses on Cisco's edge security solution. The challenge lies in selecting and configuring these solutions in a way that is both effective against threats and minimally disruptive to legitimate user activities. The correct approach represents best professional practice because it prioritizes a layered security strategy that aligns with the principles of defense in depth, a core tenet of network security. By focusing on the specific security controls and technologies covered in the SENSS exam, such as firewalls, intrusion prevention systems, IPS, VPN, and access control lists, ACL, the administrator can implement a comprehensive security posture. This approach ensures that security is not an afterthought but an integral part of the network design and operation, directly addressing the exam's focus on implementing Cisco Edge Network Security Solutions. Adherence to best practices in configuration and policy management, as taught in the SENSS curriculum, minimizes the attack surface and reduces the likelihood of successful breaches. An incorrect approach that focuses solely on blocking all traffic without proper analysis is professionally unacceptable. This is because it fails to distinguish between malicious and legitimate traffic, leading to denial of service for legitimate users and impacting business operations. Such an approach ignores the principle of least privilege and can be overly restrictive, hindering productivity. From a regulatory and ethical standpoint, while not explicitly tied to specific U.S. regulations in this context, it violates the ethical obligation to provide a functional and secure service. Overly broad blocking can also lead to unintended consequences, such as blocking critical business applications or services, which could have financial repercussions for the organization. Another incorrect approach that relies on outdated or unpatched security software is also professionally unacceptable. This directly contradicts the principles of proactive security management emphasized in the SENSS curriculum. Outdated software often contains known vulnerabilities that attackers can exploit, rendering the security measures ineffective. Ethically, this demonstrates negligence and a failure to maintain a secure environment, potentially exposing the organization to significant risks. This approach fails to keep pace with the evolving threat landscape. Critical consideration in edge network security. A third incorrect approach that neglects to implement proper logging and monitoring mechanisms is equally problematic. While implementing security controls is crucial, the ability to detect, investigate, and respond to security incidents is equally important. Without adequate logging, it becomes impossible to identify the source of an attack, understand its scope, or implement corrective actions. This failure to monitor and audit security events is a significant gap in a comprehensive security strategy and can lead to prolonged breaches and increased damage. It also hinders the ability to comply with potential future auditing requirements. The professional decision-making process for similar situations should involve a thorough risk assessment, understanding the organization's specific security requirements and threat profile, and then applying the principles and technologies taught in the SENSS curriculum. This involves a systematic evaluation of security controls, their configuration, and their impact on network operations. Professionals should prioritize solutions that offer granular control, robust threat detection capabilities, and the ability to adapt to changing threats, all while ensuring minimal disruption to legitimate business functions. Continuous learning and staying updated with the latest security best practices and Cisco technologies are paramount. Question 20. Examination of the data shows that a healthcare organization is implementing a new network segment to support a research initiative involving patient data. The organization operates under U.S. federal regulations, requiring strict protection of protected health information. 5. The network security team is tasked with ensuring the edge security of this new segment is compliant and robust. Which of the following approaches best aligns with the regulatory framework and professional security best practices for this scenario? Option A. Implement a comprehensive set of Cisco security features on the edge devices, including zone-based firewall policies, intrusion prevention system, IPS, signatures tailored to common healthcare threats, and secure VPN connectivity for authorized researchers, all configured based on a documented risk assessment and aligned with NIST SB 800-53 controls relevant to PHI protection. Option B. Prioritize the rapid deployment of network connectivity for the research team by disabling certain security features on the edge devices that are perceived as slowing down access, with a plan to address security later. Option C. Focus on implementing advanced encryption protocols for data in transit without a clear understanding of the specific access control requirements or threat landscape for the research segment, as encryption is a universally recognized security measure. Option D. Deploy the latest Cisco ASA firewall model with default security settings and enable basic logging, assuming that the vendor's default configurations provide adequate protection for PHI. The correct answer is A. Implement a comprehensive set of Cisco security features on the edge devices, including zone-based firewall policies, intrusion prevention system, IPS, signatures tailored to common healthcare threats, and secure VPN connectivity for authorized researchers, all configured based on a documented risk assessment and aligned with NIST SB 800-53 controls relevant to PHI protection. Explanation. This scenario presents a common challenge in network security, balancing the need for robust security controls with the operational requirements of a business, all while adhering to specific regulatory frameworks. The professional challenge lies in interpreting and applying the nuances of the chosen regulatory framework to a practical network security implementation. The chosen regulatory framework for this exam is U.S. federal regulations, specifically those pertaining to the protection of sensitive data, such as HIPAA or NIST guidelines, as they are commonly encountered in U.S.-based organizations. The correct approach represents best professional practice because it prioritizes a systematic, risk-based methodology that aligns security controls directly with identified vulnerabilities and regulatory mandates. This ensures that resources are allocated effectively to address the most critical threats and compliance requirements. By involving relevant stakeholders and documenting the process, it fosters transparency and accountability, which are crucial for demonstrating due diligence in a regulatory audit. This approach directly addresses the spirit and letter of U.S. federal regulations by focusing on the protection of sensitive information and the establishment of a secure network environment. An incorrect approach that focuses solely on implementing the latest security technologies without a clear understanding of the specific regulatory requirements or the organization's risk posture would be professionally unacceptable. This is because it may lead to misallocation of resources, the implementation of unnecessary or ineffective controls, and a failure to meet specific compliance obligations. For example, implementing a complex intrusion prevention system without a risk assessment to determine its necessity, or without configuring it to detect specific threats relevant to protected health information. 5. Under HIPAA would be a failure to comply with the reasonable and appropriate safeguards requirement. Another incorrect approach, such as relying on vendor default configurations for security devices, is a significant regulatory and ethical failure. Vendor defaults are rarely optimized for specific security needs or compliance requirements and often contain known vulnerabilities. This demonstrates a lack of due diligence and a failure to implement adequate security measures, directly contravening the expectation of proactive security management under U.S. federal regulations. A third incorrect approach, which involves bypassing security controls to expedite network access for a specific department without proper authorization or risk assessment, is a critical failure. This undermines the entire security framework and creates significant compliance risks, particularly if the data being accessed is sensitive. It demonstrates a disregard for established security policies and regulatory obligations, potentially leading to data breaches and severe penalties. The professional decision-making process for similar situations should involve a structured approach. 1. Understand the specific regulatory framework applicable to the organization and the data being handled. 2. Conduct a thorough risk assessment to identify vulnerabilities and threats. 3. Map security controls to identified risks and regulatory requirements. 4. Prioritize implementation based on risk and compliance impact. 5. Document all decisions, configurations, and justifications. 6. Obtain necessary approvals for any deviations from standard procedures. 7. Regularly review and update security measures and compliance adherence.